Assalamualaikum and greetings, ladies and gentlemen. Do you know that protection device in a test distribution system need to be monitored frequently? This is because to ensure that protection devices are in good condition and can take a quick action if the devices are malfunction. This is one of the example of the test distribution system. It is well known as IEEE 34-node system that consists of feeders and lateral line. In this distribution system, there are many types of protection devices have been installed such as circuit breaker and fuses. If there are overcurrent occur at feeders or lateral lines, the fuses will be blown out and the circuit breaker will be tripped off. There will be multiple protection devices installed in a distribution system. How to identify specifically a malfunction or faulty protection device in distribution system? Most of the method requires information from alarms and protective relay. For an example, by using artificial neural network ANN or combine it with fuzzy logic approach. However, most of distribution systems are not completely equipped with alarm relays. If the method does not need alarm and protective relays information such as SCADA and energy management system approach, it requires high implementation and high cost. Therefore, to avoid using information from alarm and protective relays, a new approach has been proposed, which is by using combination of adaptive neuro-fuzzy inference system (ANFIS) and feed-forward neural network (FFNN), which are tools that available in MATLAB. The basic of ANFIS structure consists of 5 main processing stages, namely input fuzzification, application of fuzzy operators, application method, output aggregation, and defuzzification. The principal work for ANFIS usually is having multiple inputs and a single output. The distribution system uses 3-phase electric power, which are usually called phase A, phase B, and phase C. Thus, the multiple input for the ANFIS are current fault for each phase, which are IA, IB, and IC. Current fault is occur when there is a fault happens at the feeders or lateral lines. Then the output of ANFIS will be in terms of binaries 1 and 0s. This binary will be represented as the operating status of the protection device, where 1 will be interpreted as operating and 0s as non-operating. The output of ANFIS will be input for FFNN for more accurate reading. FFNN will produce a decimal point number instead of single number like ANFIS, because predicted values will be in a decimal point number. With that, it can reduce the absolute error. There will be a combination of one ANFIS and one FFNN forming a main block. Based on the test distribution system before, there are 2 circuit breakers CB, 9 fuses F, and 2 additional backup protection device CB1 and CB2. The main block 1 until main block 11 will represent each equipped protective device in the test system, namely CB1, CB2, F1, F2, F3, F4, F5, F6, F7, F8, and F9. For main block 12 and main block 13 are represent backup protection device for respective CB1 and CB2. Thus, there will be 13 main block in a total for this particular distribution system. After rounding up output of the main block, the result will be 0 or 1. When referring to current state of all protective device, the example of possible state that will come out is 0000001 00000. In this case, 6 digit in 1, which correspond to the faulty state of fuse 4 because it is still operating even though the fault has happened. This is the best thing about my research. It can specifically tell which a faulty protection device in a test distribution system, and at the same time can reduce absolute error. The lesser the absolute error, the better the system. So I truly believe that the combination of ANFIS and FFNN tools for identifying faulty protection device has high potential and can advance power electronic technology. With that, ladies and gentlemen, thank you for your kind attention.